Alright, so let's look at this question here, which is on discrete random variable taken from the year 2017 paper to question 5 of the H2 math paper. So a bag contains 6 red counters and 3 yellow counters. In the game, cards remove counters at random from the bag one at a time until he has taken out 2 red counters. So the total number of counters cards removed from the bag is denoted by T. Find PT equals to T for all possible values of T. Okay, so he said essentially what's going on here is as long as he picks 2 counters out, then you will be able to stop the game. Okay, so you just stop it. So firstly, the most straightforward one is actually picking right off the bat. Just pick 2 red, right? 2 red, then you will just stop. So first thing is to understand that you have got in total 9 counters, 9. So if this is basically just T equals to 2 just means draw twice. So you have R, right? So it will just be 6 over 9 multiplied by 5 over 8. Okay, that's it. This will be 5 over 12. Okay, that's all. So obviously, then we have got PET, which means drawing 3 balls. 3 balls will just means that P, first 2 can be 1 R and 1 yellow, right? Then the last one has to be R. Okay, that's the case there. So this is what's going on. The last one you have to fix. So it's 9 times 1 over 8 times 7. Okay. So here, multiply by 7, the last one. But so you will 1 red and 1 yellow, just be 6 multiplied by 3. But you need to multiply by 2 factorial because the red and the yellow can swap places. You don't swap 3 factorial because you want this R to be held for the third one. If this R move, if you multiply by 3 factorial or 2 factorial, this R move to the front, then it will overlap with this case here. You just understand that the last guy has to be red. So fix the red behind. Then this guy will be 5. Okay, so this is the probability here. 5 over 14. Great. Then after which we have got PT equals to 4. 4, you draw 4. The last one always has to be red. So this over here you have 2R. So it has to be 1R and 2 yellow. Right, so this will just be, the first 3 will be 6 over 9 multiplied by 3 over 8 multiplied by 2 over 7 multiplied by 3 factorial over 2 factorial multiplied by last ball, which is 5 over the red ball, which is 5 over 6. Okay, so remember this is 3 factorial over 2 factorial because the number of ways to arrange R, Y, Y. The yellow counters are actually identical. So then PT equals to 5. There'll be P 1, 2, 3, 4. Then the last one has to be R. Then this in front you have 1 R and 3 Y's, right? Okay, you exhaust all the yellow counters. So that's the idea there. So similarly, it'll be 6 over 9 multiplied by 3, 8, 1 over 7 times 1 over 6, then multiplied by 4 factorial over 3 factorial, which is 4, multiplied by the last one, which is 5 over 5. Okay, then you just key in calculator. There you go. So done. Then we're going to look at part 2, variance. Finding ET and variance T, I think it's not too bad. So we're just going to use the formula. ET is just a weighted average. So we have got 2 multiplied by, so it's 2 multiplied by 5 over 12 plus 3 multiplied by 5 over 14 plus 4 multiplied by 5 over 28 plus 5 multiplied by 1 over 21. Key in calculator. There you go. Then look at ET square because we know finds variance T. So this will give us variance T as 75 over 98. Okay, that's that. So let's look at the subsequent part. So let's look at the third part. Lee plays this game 15 times. Find the probability that Lee has to take at least 4 counters out of the bag. Okay. At least 5 of his 15 games. So essentially what we want is this is the condition that you want to fulfill, right? So just write it down. It's a binomial distribution here. So this condition here is let X be the number of games where Lee has to take at least 4 counters. Okay, so this is actually probability of t at least 4. So this is x is binomial. You play 15 times, pt at least 4 will mean that we just add 4 and 5 together, 528 plus 1 over 21. So this is 19 over 84. So x is binomial distribution, 15, 19 over 84. Okay, so the required probability, at least 5 of his games out of the 15. So this will be 1 minus px at most 4. Just key in calculator. That'll give us 1 minus binomial CDF 15. The p value is 19 over 84. Then the x value is 4, right? Key in 0.23791. Okay, so that's how we do this question here proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.